What's going on, guys? Today I'm super excited to bring you a brand new Nest.js Microservices build. We're going to be creating a brand new microservice from scratch. This is going to be a real working example application that includes JWT authentication between our microservices. We're going to persist data inside of a MongoDB database, and we're going to use RabbitMQ as the message broker between our services. RabbitMQ is great. It's going to allow us to build a distributed application that can scale up to several different running containers at once. And it's also going to allow us to build a fault-tolerant messaging system that will allow us to replay messages that have failed. So without further ado, let's jump right in. Just a quick note, I'm going to be separating the deployment out into my next video. So if you'd like to see us actually deploy this application to AWS, make sure you stay subscribed and keep an eye out for that video. Okay, so we're ready to go ahead and start creating our Nest.js microservice app. And to do this, we're gonna create a workspace with the Nest CLI, which, if you're familiar with a Monorepo, will allow us to have a single code base where we can store all of our different microservice apps and all of our common libraries where we can share code between them. Now, as always, I'll have this entire project in a GitHub repo, and I will include a link in the description so you can feel free to follow along. So let's use the Nest CLI to create a new app. So we'll use Nest new, and we'll call it ordering app. Then we'll go ahead and use npm to scaffold our project and install our dependencies. So now we can go ahead and cd into our ordering app. And now by default, this ordering app is just going to be the basic Nest application out of the box. In order to actually convert it into a monorepo, we're going to use the CLI again and actually generate an app. And now we can actually create our different microservice apps within this monorepo. So let's go ahead and create our first and primary app called orders, which will actually be responsible for taking in the API requests for our orders and dispatching appropriate events to the different other services. So we've gone ahead and created a new app, orders, and converted this project into a monorepo. So we can go ahead and open it up in a code editor and take a look at the project now. So you can see out of the box, we actually have this Nest CLI that was created, and if we open it up, we can see that it has been converted to a monorepo. And we can see the projects here. So by default, it did convert our original application into an app. And then we have our other app that we just added, the orders app. And importantly, the benefit of this is that they're all going to share the same common TS config that we have at our root, as well as our ESLint.js. And they even share the same dependencies and package.json out of the box. So to clean things up a bit, we can actually remove this original ordering app from our application here. Then we can also remove it from the Nest CLI. So let's go ahead and remove ordering app. And then let's change the root here to orders, because now our root application is the orders app and not the ordering app. And then make sure you also change the tsconfig path here to apps orders tsconfig.app.json. So now that we've created our base monorepo, it's very easy to add additional microservices and common libraries to our app. So let's go ahead and do that by finishing adding our other apps. We'll go ahead and run nest generate app, and then we'll add a billing application to our monorepo. So we have our billing app, and then lastly, we'll add our final app called auth, which is going to have all of our authentication. So back in our editor, we can see we have two new folders created with the default Nest.js Bootstrap out of the box. We get the app.listen at port 3000, and you can see by default, it creates a tsconfig that will simply extend our root tsconfig. So we get these apps created out of the box. And we can see our Nest CLI has also been updated so that we know how to find these if we want to run them. And we can actually do this by opening up a terminal. And as we would, we could always run npm run start dev. And this would start our default application out of the box, which would be our orders app, which we first created. If we wanted to start a different application like our billing app, we just provide the name, and now we'll start the billing application. So let's close down this app, and let's add one more part to our application, and that's our common library. So if we want to share code between these different microservices, we'll do it by creating a new library. So let's do that by running nest generate library common. And then it'll ask us if we want to use a prefix. We'll use the default @app here. And so now we should see a new folder created called libs. And now inside of libs, we have a common library. And under here, we have a source directory. And this index.ts is simply exporting common services, modules, and other utilities that our applications can share. And if you go ahead and look in our Nest CLI, we can see our common library was added. And you can see the difference here is the type is of type library, because you wouldn't actually start this application, but you would import this code into your existing apps. Now, the first step in our project, we're going to go ahead and add MongoDB to our application so that we can persist data. In our case, actually persist the orders that the users are creating in our system. So in order to do this, I'm going to take advantage of some code we've already written in a previous video. And so if you haven't seen this video about going through MongoDB and Nest.js, I'll include a link in the description. So for now, what I'm going to go ahead and do is I'm going to take those files from that project that allow us to work with Mongo and include it in our common directory. So inside of common in the source directory, I'm going to go ahead and delete everything we have so far. And then I'm going to paste in a few files here. And like I said, this whole project is in GitHub, so you can easily get access to these database files here. But basically all we have are 4 different files. The first of which is an abstract repository, which will expose methods that will allow us to create, find one and update, and upsert documents. Additionally, we're going to have the ability to find documents and start a new transaction, a new database transaction, which we will actually delve into a little bit later, and we'll go over this in detail. So we have an abstract repository that we can extend and get all this common data access functionality. We then have an abstract schema, which is simply a schema document that specifies the _ID property, which all of our documents will have. Then we have the database module itself, which will actually instantiate the Mongoose module and pass in the MongoDB URI from a config service, which will take it from an env file. And we'll go over this in detail shortly. Finally, we have an index.ts file, which just goes ahead and exports these files to the rest of our application. So let's go ahead and create a new database folder inside of the source directory. And let's go ahead and move those 3 files, keeping the index.ts at the top here. And then we can go ahead and update our path here to these files in our index.ts so that we're correctly exporting them. So let's head back into our abstract repository. And of course, right now, we're not going to have access to these dependencies because we haven't added them. So we'll go ahead and open up a new terminal, and we'll simply install Mongoose to start. Now, this Monorepo is the same as any other project out of the box. When we install a dependency, we'll have access to it in all of our apps and common libraries. So next, if we go into our abstract schema, we can see we also need to install Nest.js /mongoose. And finally, if we go into the database module itself, now we can see we need to import the Nest.js config package. So let's install npm Nest.js /config. And this, like I said before, will allow us to extract information from environment variables. And so it'll be important that when we do use this database module in our application, that we have this MongoDB URI as an environment variable. So now that we have this common database library, let's go ahead and start using it in our orders app so we can actually persist orders. Before we do so, we can feel free to go ahead and open up our terminal and start dev and provide the name of the app we want to start. So in this case, it's orders. And make sure we say npm run start dev, which is your application correctly started up. And by default, we will be listening on port 3000. If we open up our main.ts, and we can verify this by opening up Postman and sending a GET request to localhost /3000. So let's go ahead and launch a GET request, and we should see hello world coming back from this API. So let's first open up our orders.module, and let's set this module up so that we can use our new database module and actually persist data. So first off, we're going to need to actually instantiate our config module, because if you remember, our database module will be using it in order to get access to the MongoDB URI. So we can simply import the config module from at nest.js/config. So we call config module.forRoot, and we can provide some options here. Let's go ahead and set it to global so that the config module will be globally available in our entire orders application, and we don't need to keep re-instantiating it. And then we can go ahead and provide a validation schema. So this will essentially make sure that we have certain environment variables defined, and if they're not defined, we will throw an error when starting the app. So in order to do this, we need to use the Joy validation package. So we can simply go ahead and npm install Joy. Go ahead and let that install. Okay, with that installed, we can go ahead and import star as Joy from Joy up top here. Then we're going to go ahead and define the joy.object, where we're going to provide the environment variables we expect to be defined. So of course, right now, all we have is our MongoDB URI, and we're going to specify that this should be a string and that it is required to start up our app. Now next, we need to actually specify the file path for the .m file we will define, because we want to have a different m file for each of our applications. Each of our applications in our architecture is going to be running independently of one another in its own container, and it needs its own set of environment variables. So to do that, first we can actually just define a .m file in our root here, and then we'll go ahead and open it up and define our MongoDB URI. We'll set it equal to a connection string, and this connection string will leave empty for now because we haven't actually set up MongoDB in our architecture, but we can go ahead and set the file path to the m file by providing mfile path and then saying to our app, look in the .apps directory /apps/orders.m for that m file. So now that we have the config module correctly set up, we can simply import our database module. Now, if you notice, VS Code auto imported the database module from the libs folder, and that will work, but you can also provide a path here. So by default, this path will be /app, and then we can say common. So now this way our file paths aren't hard-coded, and we can rely on tsconfig to resolve these file paths here. Now that we've imported the database module, we're ready to actually create our first schema and actually create a repository to add some CRUD functionality to our orders app. So I'm going to go ahead and create a new schemas folder inside of our orders app, and I'll simply create an order schema.ts, and I'll decorate this with the schema decorator, which will import this schema from Nest.js/mongoose. And so we have this schema decorator here, and we're going to specify the version key to false because we don't want to deal with versioning in this app. So we'll export our class called order, and it will extend our abstract document from our lib common folder. And of course, we'll prefer to use the app/common import here. And if you recall, the abstract document is simply a class with the _ID property, which is the default Mongo identifier. Now inside of this class, we'll go ahead and specify a few properties here. And so make sure we import prop as well from Nest.js Mongoose. And then we can specify some different properties. So we'll have a name of the order. Then we'll specify the price of the order, which will be a number. And then we can say we will have a phone number maybe for the user in order to notify them later on after we have correctly billed them. So next we're going to go ahead and export the order schema, which will be schema factory create for class, and we'll pass in the order itself. And we go ahead and import the schema factory as well from Nest.js Mongoose. So now that we have the schema all set up, we can go ahead and create our orders repository, which will allow us to manipulate data inside of the database. So we'll create a orders repository, and this of course will be an injectable class here from Nest.js common. And so we'll export a class called orders repository, and it'll extend the abstract repository which we have set up in our common database library here. The name of the schema we're passing in, so in this case it's the order that we just created, and then we're going to have a logger that we're going to have to declare inside of the repository, and then we need to go ahead and provide a read-only logger here so that our abstract repository can log. And we'll import the logger from Nest.js common and just simply provide the name of the class. So in this case, it will be the orders repository.name. And then in the constructor, we can use the property injection inject model, which will be imported from Nest.js Mongoose. So let's go ahead and import the inject model from Nest.js/Mongoose. So we have this inject model, and then we're going to provide the name of the order schema we created. And we'll get access to the order model here, which is of type model, type order. And we import model, importantly, from Mongoose. So let's go ahead and import model from Mongoose. So now that we have the model itself, we're also going to go ahead and use the inject connection decorator. And we'll import this as well from Nest.js Mongoose. We'll go ahead and use inject connection. And this will allow us to pass up the connection to the abstract repository, which will be important for when we want to track a database transaction. So let's go ahead and label this correctly as a connection, which we import from Mongoose. So now that we have these two properties injected, we can pass them up to the parent abstract repository. And now we've done all this work, we get all the CRUD functionality from the abstract repository for free. So lastly, let's go back into our orders module, and we will go ahead and actually instantiate our orders repository here. And then underneath our database module, we will call Mongoose module, which you might expect will need to import from Nest.js Mongoose. So I'll go ahead and import the Mongoose module from Nest.js Mongoose. And then we'll call for feature and actually register our order schema. So we do this by providing an array of objects with each schema. And so in our case, we need to provide the name of the schema we're looking for. In this case, it's the order. And then we'll provide the actual order schema itself, which we created using the schema factory. So now we have everything in place to actually persist orders. We can take a look at our backend, and as you'd expect, we have an error being thrown because we have this config validation failing since we haven't defined our MongoDB URI. So let's go ahead and get MongoDB up and running so that we can connect to it. Okay, so we're ready to start up our app and MongoDB. In order to do this, we're actually going to use Docker Compose. Now, Docker Compose is a tool that allows us to start up multiple Docker containers at once in a single application. So we're going to do this in our application by starting up each of our microservices independently and all of our dependencies. So we'll start up MongoDB along with our microservice apps. So let's dive into this. First, we're going to create a Docker Compose.yaml. Now this Docker Compose YAML will be a list of instructions to Docker on which images and containers to start when we want to start our application up. Now we want to start up MongoDB to begin with. Now we could just use the base MongoDB image from MongoDB. However, we're going to need to start up a replica set in MongoDB in order to use the database transaction functionality. And in order to do that, we can open up our browser and let's Google for Bitnami MongoDB. Now Bitnami is a image provider, and they have an image for MongoDB, but they also have one that allows us to create a replica set very easily and make use of advanced functionality like database transactions. So I'm on this GitHub page for Bitnami Docker MongoDB. I'll include a link in the description, but what we're concerned with here is the Docker Compose replica set. So let's go ahead and open this up. And if we open this up, we can see a list of services that we want to start up. So in this case, we have a MongoDB primary node, a secondary node, and an orbiter. Now we don't really care too much about what's going on behind the scenes. We just need to be able to start up this replica set. And we also have a volume which will allow us to persist data between application restarts. So let's go ahead and just simply copy this entire YAML file and paste it in to our Docker Compose. So now we should have 3 services, and we can see that we're pulling the image from the Bitnami MongoDB here. And we're also specifying some environment variables. And lastly, we specify the volume that we want to use in this case MongoDB master data, with a local driver so that we persist this data. Now the only thing I'm going to add here is for our MongoDB primary, I'm going to go ahead and add a port section. So let's go ahead and specify that we want to use port 27017, and we want to map this to our machine port of 27017 so that we can access the MongoDB on this normal 27017 port. So now that we have this all set up, let's open up our terminal, and in our same directory we should be able to run docker compose up. And of course you need to make sure you have Docker running and installed. And if you don't, I can include a link in the description for how to get up and running with Docker. So if we go ahead and run docker compose up, you should see that our Mongo containers are starting up. They will go ahead and run through the initialization process. So now that we have the ability to run MongoDB in a replica set in our application, we want to actually be able to run our own app inside of this Docker Compose. In order to do this, we need to specify a Docker file for each of our microservice apps so that we can use them in our Docker Compose here. So let's go ahead and do just that. We'll go ahead and start with our orders app. So let's go ahead and open up our orders directory, and let's create a new Docker file. Now I'm going to go ahead and paste in a list of instructions for how to build this Docker image. Now I have a separate video where we delve deeper into each of these instructions and learn more about how Docker works in Nest.js. So if you're interested in that, I'll include a link in the description. But from a high level, all this image is doing is providing the list of instructions for how to build our container. So you notice here we're copying over our root package.json, running npm install, copying over all of the projects, running npm build, and then finally at the bottom here we're actually starting our application using Node in the dist apps orders main folder. Now one drawback of building our images like this is that all of our microservice apps will share the same package.json and the same dependencies. So you may have a scenario where you have one app that has a lot of dependencies which the other ones don't need. And in that case, you may want to consider having a separate package.json for each app. But in our case, our apps have limited dependencies and we can share this package.json just fine. So now that we have a Docker file with a list of instructions of how to build our app, let's go ahead and create a .docker-ignore for Docker, which essentially will specify files that we want to ignore when building our image. So I'm going to paste in a list of files here, and these files are just versioning and metadata files, so .git, .gitignore, and .docker-ignore itself, but then also build dependencies like node modules, environment variables, and other miscellaneous files that we don't need in our image. We're not going to include the .m files because we're actually going to inject these environment variables in the Docker Compose itself. So let's go ahead and do that by opening up the Docker Compose.yaml. And now we can actually specify our orders service. And so what we're going to do now is specify the build section. Next, we're going to specify the build context. So this is essentially where in our directory do we want to start this build from? Well, it's going to be the root directory where we already are. Then we're going to specify the Docker file that lists the instructions for how to build this service. And of course, we know this is the one we just created. So this will be in .apps orders Docker file. Now we're going to specify a target for which part of the Docker image we want to use in this Docker Compose. Now if we take a closer look at the Docker file, we can see it's broken up into two stages: the development stage and the production stage. Production stage will only install the production dependencies, which is not what we want when we develop. We want all of the dependencies, including the development dependencies. So to do that, we can specify we want to target the development stage. And lastly, we can specify a command that we want to run the image with and essentially override the default command. Now this command would work, but we want to be able to refresh our app when we make changes easily, as in when we normally use the Nest CLI. Simply override this by providing the command npm run start dev orders so that our application will restart when it detects file changes. Now let's go ahead and specify the M file, which I talked about earlier. And of course, this will be in apps orders.m. And so this will load the environment file that we specified here and inject all these environment variables into our container. Next, let's go specify a section called depends on, which will simply be a list of services that we need to start before we start this one. So in our case, this will be the MongoDB nodes. So we want the MongoDB primary, secondary, and MongoDB orbiter to be able to run before this one starts. Then we're going to specify a volume section. So we're going to go ahead and mount our entire application into the user source app directory, which, if we remember, is the working directory for our image. And the reason why we do this is because we want to be able to detect if there are any file changes, and if there are, we want to reload the application. Finally, we're going to provide one more volume here, and this will be user source app node modules. And this is a bit of a hack to specify that we don't want to mount our own node modules inside of our project here, but we want to maintain the ones inside of our running container so that we don't include any node modules that are just part of the machine that we're running on. So we have our volume set up, and now we'll specify a port. So of course we know that this application will be running on port 3000, and we'll expose port 3000 on our host machine as well. So now we should be able to go ahead and start up our orders application as part of our image. So let's go ahead and run docker compose up. Now I'm going to run that -build and then -v to reset all volumes because we have a new image in our docker compose. So you can see it's going ahead and building orders based on the Docker file that we have specified. So after we start up our images, you should have seen the orders container flash by. And if we scroll back up a little bit, we should be able to see our orders container. And of course, we still have the same error about the MongoDB URI being empty because we still haven't provided the MongoDB URI. So let's go ahead and do that. In our .m file, we will now provide the MongoDB URI. So this connection string will be MongoDB, and then we go ahead and provide the username and password. Now, by default in Bitnami, the default username will be root, and then we can see that our password here is password 123. So we'll go ahead and provide the password as well, and then we specify @ and then we'll specify the host. Now, since these containers are all running inside of Docker, we can actually use the name of the service itself to connect to it. So in this case, it will be MongoDB primary, and then of course the port 27017. And then we have our connection string in place. I've gone ahead and restarted my containers, and we can see them starting back up. Now we can see our orders application successfully starting, and if we give it a little bit, we should be able to see it starting once Mongo finishes. Yep, so here we see our Nest application has successfully started for our orders container. So now we have a MongoDB full replica set running, as well as our orders service, all in one application using Docker Compose. So we're actually ready to start developing our orders app and allowing the creation of new orders. So let's get started by opening up our orders application and opening up our orders controller. Now, just so you remember, whenever we make a change to our orders application, like for example, just putting in a comment here, we should expect to see our application fresh and restart. So let's go ahead and start by opening up our orders controller, and let's get rid of this default get route here. We'll go ahead and create a new post route that will allow us to create an order. So we'll call this async create order, which will of course take in a body that we'll call request, and this will be of type create order request, which we will shortly define. And we're essentially going to just return this .order service .create order and pass in the request. Now we need to go ahead and define the create order request. Let's go ahead and create a new DTO folder, and then we can create the create order request. So now we have this DTO we can define. Let's create a create order request. And now we want to apply some validation, and you probably guessed it, we can use class validator. So let's open up our terminal and install class validator so that we can easily validate our DTOs. Additionally, make sure we go ahead and install class transformer, which is required for the class validator package to work properly. Now we have this class validator package. We'll go ahead and provide 3 properties. We'll have a name of the order, the price of the order, and the phone number of the user that created it, which will be a string in our case. So we can provide some simple validation to these properties. For the name, we should expect it to be a string, and it should not be empty. The price should just be a positive value. And lastly, the phone number actually has its own validator called isPhoneNumber, which will validate that this is a valid phone number with a country code. So now we have this validation out of the box. We need to open up our main.ts file and make sure that we actually apply the global pipe. So we'll call app.useGlobalPipes and then call new validation pipe from Nest.js common. So while we're here, we also want to make sure we're not hard coding our port, because this will make it difficult when we want to deploy our application in a different environment. So let's go ahead and pull the config service from the app. We will call app.get config service. Let's provide the config service.get and provide the port here. Now we'll actually need to provide this value in our .m file, but this is simple. We'll just provide a port of 3000. Additionally, let's open up our orders module and add another validation here, number, and this should also be required. So back in our orders controller, let's go ahead and import the create order request. So now we've correctly imported it. We can get rid of this get import. We now can go into our orders service. Now we can actually persist the order. So let's create a new async create order function, which takes in the request of type create order request. Now all we want to do right now is simply persist this to the database, and that is all. So let's go ahead and inject the orders repository that we created earlier. So this will be a private read-only orders repository of type orders repository, and all we want to do is return this .orders repository.create, and we'll go ahead and pass in the request. So now if we go back to our terminal, we should see some issues that class validator is not defined. Well, this doesn't really make sense because we did install it. The problem is that whenever we add a new dependency, we need to make sure we start up our application with --build and -v to make sure we force the containers to rebuild. After restarting our containers, we should see our orders application starting up successfully again. So we're ready to test this API out, and before we do so, let's just go into our orders controller and provide the controller with an orders name so that we have the correct name for the API. And then we should be able to open up Postman and launch a post request to localhost 3000/orders. Now I have a body set up here with the name of t-shirt, a price of $39.99, and a phone number with an area code, importantly. So if we send off this request, we can see we get a 201 created back. And if we were to, for example, send a request with no price, for example, we can see our validation working properly. Okay, so now that we can create an order, let's add a route so that we can retrieve existing orders to make sure our database is actually persisting orders correctly. So let's go ahead and add a get route here. We'll call it get orders, and it will simply return this.orderService.getOrders. And we can go ahead in the orders service and create a get orders function. And all we're going to do is reach out to the repository, make a call to find with a empty filter query, so we retrieve all orders. Make sure we save our controller here, and let's go ahead and open up Postman again and launch a get request at our orders API. So now inside Postman, I'm going to go ahead and send a get request here, and then we can see a number of orders that I have created coming back in an array here. So now we're ready to start connecting the microservices in our application. We're going to start by initializing our billing application as a RabbitMQ microservice. So to go ahead and do this, we're going to open up the terminal and add a new dependency. So this dependency will be at Nest.js/microservices. So make sure we go ahead and install this. So after we install Nest.js Microservices, we're also going to need AmpQplib and the AmpQp connection manager to establish a connection to RabbitMQ. And then what I want to go ahead and do is I want to go ahead and in our libs folder, in our source directory, let's go ahead and create a new folder called RMQ to stand for RabbitMQ. And what I want to do is create a new RabbitMQ module that will encapsulate all of our RabbitMQ related functionality. So let's go ahead and create a class called RabbitMQ module, and we'll decorate this with the module decorator from Nest.js Common. And now let's also go ahead and create a new RabbitMQ service. Now this RabbitMQ service will be an injectable class that we'll call RMQ service. And like I said before, this service will allow us to encapsulate common RabbitMQ functionality. So the first functionality we're going to add is a method called getOptions, which we can use for each microservice to call when they're initializing it, so we can provide a single place where we configure all the options for our RabbitMQ microservices. So we're going to need to get the name of the RabbitMQ queue that we want to initialize. And then we're also going to add a property called noAC and set it to false by default. Now in RabbitMQ, we have the ability to say that we want to manually acknowledge a message before removing it from the queue. By default, Nest.js will automatically acknowledge all these messages. So if we want to handle this acknowledgement manually, we need to specify it so. So let's go ahead and return an object. Now we can also specify the return type on this method and say that this will return the RabbitMQ options from Nest.js Microservices. And then we're going to specify the transport. Well, we know, of course, the transport will be RabbitMQ. And then we have an options object here. So in order to provide some options for our RabbitMQ microservice, we're going to go ahead and inject our config service so that we can get access to environment variables. So let's go ahead and import that. And now we're going to provide a list of URLs. So this is going to be the URLs where RabbitMQ is listening on, or our brokers. So it's an array, and then we'll call this .configservice.get. It'll be a string, and then we'll call it RabbitMQ URI. So like before with MongoDB, we're going to need to make sure that this environment variable is available in any service where we're using this. And so now we can provide the actual name of the queue that we are creating. So let's call this .configservice.get. This will be a string. And then we'll provide a template literal here where we'll say RabbitMQ queue will be the queue that has been passed into us, and we'll call this queue. So the queue that's passed into this options function will be the environment variable that we're extracting. Lastly, we'll provide that noAC property, and then we'll say persistent true so that we maintain our list of messages. So now that we have this common functionality to initialize a RabbitMQ microservice, we can go ahead and open up our billing application main.tf. And firstly, we're going to go ahead and get access to that RabbitMQ microservice by calling this .app.get RMQ service. And then we will provide the name of RMQ service. I'm going to go ahead and change the import here to be from app.common. And you can see here we're getting a complaint that app.common has no exported member RMQ service. And that's because in our index.ts, we need to actually go ahead and make sure we export it from rmq.service. Lastly, in our RMQ module, we'll go ahead and make sure that we actually provide the RMQ service here, and then we can list it as an export. So we'll go ahead and list that as an export. So now back in our main.ts, we have access to the RMQ service. We're going to call app.connect microservice. And now we're going to pass in the RMQ service.getOptions. And now we're going to provide the name of the queue that we want to create. So in this case, this is the billing application. We want to create a billing queue for messages to listen on. So we'll pass that name in. And secondly, we're going to set noAC to false by keeping the default, because we want to manually acknowledge messages we receive. And in case of a failure, we want to replay a message. So we're going to leave those options as they are. And then instead of calling app.listen, we'll call app.start all microservices. And this is all we need to do to start up a RabbitMQ microservice. Make sure we also import the RMQ module here from the app.common, And if you recall, as we did earlier, we're going to need to go ahead and export the RMQ module. So let's go ahead and do that. We'll just copy the RMQ service and change this to module. So now that we have the RMQ module imported, you'll recall that we need to create a set of environment variables for our billing application. So let's go ahead and create a .m file. The first environment variable we need, of course, is the RabbitMQ URI. So we'll leave that empty for now until we have RabbitMQ actually running, but we can also specify RabbitMQ billing queue, because as you recall, in our main.ts we passed the name billing in, which corresponds to this environment variable. So we need to make sure we have this available, and we'll call this queue billing. So now we actually want to start our billing application. We're going to go ahead and do the same thing we did with our orders application by creating a Docker file in here so that we can containerize this app and run it as part of our Docker compose. So let's go ahead and open up our original Docker file, and we'll simply copy everything over into this one. We're just going to need to make a change down here when we start the application to make sure we go into the billing. But other than that, the steps to create the application are exactly the same. Now let's go ahead and open up our Docker compose so we can actually set up our billing application. So this is going to be almost exactly the same as orders. So we'll go ahead and actually just paste our existing configuration for the orders application. However, we're going to go ahead and change the name to billing. And then we're going to change the path here to the Docker file to be in the billing project. We're still going to target the development stage. And now when we start the application, we want to start the billing app. So make sure we change that. We'll change the path for the environment file. We'll keep our volumes exactly the same. And then we can remove this port here because we won't be using it. So while we're here, we can also easily add a RabbitMQ service. And we can do this by creating a new service called RabbitMQ, and we'll provide the name of the image. So in this case, we'll use the default RabbitMQ image hosted on the Docker Hub repository. And that's all we have to specify. Then we'll specify the port here that we want RabbitMQ to be exposed on. So this will be 5672 in the container and the host machine. So this is really all we need to get RabbitMQ running, quite easy. And so now that we have RabbitMQ, the ability to run it, let's open up our billing m file where we have the RabbitMQ URI. And now we can specify the URI, which is going to look like this: ampq:// This will be the host. So since this is Docker Compose, we give it the name of the container, which in our case is simply RabbitMQ. So this will be RabbitMQ, and then of course the port we specified was 5672. And this connection string here should actually be AMQP. Now additionally, we need to instantiate the config module in this billing module because RabbitMQ is going to use it. So let's go ahead and call config module for root here, where we'll specify that we want it to be globally instantiated, and then we also want to provide some validation as we've done before. So we'll use our validation schema here. We'll go ahead and import joy by calling import star as joy from joy, and then we can call joy.object, and then inside this object here we of course know that we have two environment variables. So let's go ahead and provide them. We have the MongoDB QURI, which will be a required string, and then we have the actual name of the billing queue, which we will want. So let's go ahead and provide this by labeling it as a required string as well. Now let's go back to our terminal and stop all of our containers. Since we've installed some new dependencies, next time we start, we're going to run docker compose up --build -v. So go ahead and let these containers finish building and running. So in our logs, we should eventually see the billing application come online, and you should see the Nest microservice successfully started message. So now that we've gone ahead and set up our billing microservice, let's go ahead and actually use it inside of our orders application so we can communicate with that service. To do so, I'm going to go ahead and open up our RabbitMQ module. So we're going to go ahead and create a dynamic module. So to turn this into a dynamic module, we're going to go ahead and create a static register method. Okay, and this is going to take an object which specifies the name of the service we're trying to register. And we're going to define this as RabbitMQ module options, which we can go ahead and quickly define above as an interface here. So RabbitMQ module options, which will simply take a name that is a string. So this function is going to return a dynamic module from Nest.js common. And now we can go ahead and return a dynamic module. So in this case, we're going to return the RabbitMQ module. That's the module that we're returning. Now we want to provide an imports array here. And importantly, in the imports array, this is where we actually want to register the RabbitMQ service that is being passed in here. So let's go ahead and call clients module dot register async. Now, clients module is the module that we're going to go ahead and use to register a RabbitMQ service, and we import it from Nest.js Microservices above. So this is going to take an array of services that we want to define. So let's go ahead and define the first service by opening up a new object, and we provide the name of the service here. And then we can go provide an options object, which will provide the information for how to connect to this service. So now that we specify the name of the service, we're going to use useFactory here to be able to inject the config service when we define how to connect to the service. So we need to get access to the config service, and we'll import this from Nest.js config and go ahead and return an object here. So inside this object, you need to specify the transport that we actually want to use for this microservice. So of course, for our case, we know this is going to be RabbitMQ. So we can go ahead and define that. And then we have the actual options object, which defines how to connect to this server. So I'm going to go ahead and define the first property, which is URLs, which will be the URLs that our RabbitMQ server is actually listening on. So of course, in our case, we know that we can extract this from the config service. We'll call get, give it a type of string, and we know that this will be the RabbitMQ URI, which will of course be defined as an environment variable. And make sure we change the config service here. We have a typo, so this should be config service. So now we have the list of URLs. Now we need to define the actual name of the queue that we're trying to register here. So this will be config service.get, and as we've done before, in the RabbitMQ service, when we're actually defining the name of the queue inside of the bootstrap method, we're going to use this same exact pattern here. So to actually register the queue, we can just pull it out of the config service, and this will be the name here of the service that we're trying to register. This will be pulled from the environment variable as well. So now we have everything we need to actually register this microservice in our application. We're going to go ahead and of course inject the config service that we are using here so that we have access to it in the useFactory. And then lastly, in our dynamic module, we want to re-export the clients module here, so that the consuming module that imports it will have this clients module with the registered RabbitMQ service that we just created. So now let's go ahead and actually use this dynamic module inside of our orders app so that we can register the billing microservice and actually use it. So I'm going to go ahead and open up my orders.module here. So now we can actually import the RMQ module, and I'm going to go ahead and add the RMQ module from our app common import above, and then we can call that static register method to go ahead and actually register the billing service. So all we have to do is provide the object here. We just need to provide the name of the service here. So let's go ahead and create a new folder called constants, and then we'll create a new file called services.ts. And then I'll simply export a const called billing service, which will be the name of the RabbitMQ service that will be defined in our env, of course. So at the same time, we're going to go ahead and also open up our .env and make sure that we have firstly our RabbitMQ URI defined, which of course we know should be amqp://RabbitMQ, and then give it the port of 5672. Now we also need that RabbitMQ billing queue defined here, which will be the name of the billing queue that will be used in our RabbitMQ module. So now we can actually go ahead and reference this constant value. We'll use the billing service here. And now we have this microservice registered inside of our orders module. Now we can actually make use of it by opening up our orders.service, and we can of course inject this billing service right inside of our code so that we can actually communicate with that microservice. Now to do so, we're going to use the inject decorator here, from Nest.js common. And then we're going to provide that same billing service constant that we used in our register call to RabbitMQ module. So we have that constant value that we're injecting here, and I'll go ahead and call this the billing client, which will be of type client proxy from Nest.js Microservices. So now that we have access to the billing client and can actually communicate with that billing service, let's go ahead and refactor our create order function. Now in this function, what I want to do is only if we are able to successfully create an order, then I want to emit an order created event to our billing microservice so that we could go ahead and bill the user. So in order to accomplish this, we can take advantage of database transactions in MongoDB. So if you're not familiar with database transactions, they essentially just allow us to ensure that we only perform some functionality if our database calls succeed, and if not, we don't perform that functionality. So to see this in action, let's go ahead and create our database transaction by calling this.ordersRepository.start transaction. And if we take a quick look at what this is doing in our abstract repository, all it's doing is starting a session and then starting a transaction on that session and returning it. So let's go ahead and open up a try catch block here. So firstly, we can actually just say in the catch block, if any error were to occur, we're going to go ahead and call session.abort transaction, which will abort the current active transaction in this session and cancel any database calls. So we don't actually persist the order if something were to go wrong here. For example, we couldn't communicate with our billing service, so that this entire transaction here is atomic, and we don't persist the order if we aren't able to bill the user. So we'll also throw the error here if we do get an error. In the try block, what we're going to go ahead and do, of course, is actually try to create the order. So we'll call this.ordersRepository.create. We'll pass in the request, and then we're going to pass in the session here. So now that we've actually tried to create the order, let's go ahead and emit the order created event. Now this billing client will return us an observable, and we want to convert this into a promise. So I'm going to call await last value from, import this from RxJS, and then we can call this.billingClient.emit. So we're going to go ahead and emit an event to our billing microservice, and we're going to call this order created. Next, we can actually specify the data we want to send through. And in our case, I'm just going to go ahead and pass the exact request that was passed in to this function, or the create order request itself. So if we are able to successfully send this message to the billing client, then at that point, we can call session.commit transaction, which will actually go ahead and commit this database transaction, persisting the order to the database. And finally, we'll go ahead and return the order. So with this in place, let's go ahead and open up our billing application. In our billing controller, we will go ahead and set up this to be able to receive this event. So this is quite simple to do. We can simply decorate a new controller function here with the event pattern decorator, which allows us to specify the event we want to listen to. So in our case, we know this will be order created, and we'll go ahead and call this handle order created. Now inside of this function, we can get access to the payload from Nest.js Microservices, which will be the actual data that we passed in our case, the create order request itself. We can also get access to the context here, which is going to be a set of information about this request from RabbitMQ. So this will actually be a type RabbitMQ context from Nest.js Microservices. So with this information, I'm going to go ahead and call this.billingService.bill, and we'll pass in the data. And so let's go ahead and open up the billing service. Now inside of here, it will be quite simple. All I want to do is I want to create a logger that will be specific to this billing service. So I will create a new logger from Nest.js common and pass in the billing service.name. I'm going to go ahead and create that bill function, which takes in the data, and I'm just going to log it out. So we're going to call this.logger.log and say that we're billing based off of the data we have received. So with all this in place, we should now be able to open up Postman. And of course, like we did before, we can send a request to localhost 3000/orders. So this is our orders application, and we can place an order with this body here where we provide a name, a price, and a phone number. Now if we go ahead and send this request to our orders application, we get our order back persisted in the database. But now if we look at our logs here, we can see in our billing application, we actually are logging out this billing statement here with the request that is coming from the orders application. So we are able to communicate between microservices, and you could imagine this billing service, we would be billing the user based off of this information here. Let's go ahead, and all I'm going to do is just save this billing controller again. I'm just going to save this file and restart the billing application. Now if you notice, when we restarted the billing application, we actually logged out this request again without having to send another request. So if I just save again, you can see the application restart. And again, we're replaying these messages off of the RabbitMQ queue. And so why is this? Well, the reason this is because if you look at how we set up our RabbitMQ service here, we set no ACK to false by default. So what this means is that we need to manually acknowledge that we have processed a message so that RabbitMQ can take it off of the queue and we don't keep replaying it. And so this can be useful if we want to handle message failures, but we also need to make sure we do acknowledge our messages when received. So let's go ahead and take care of this. In the RabbitMQ service, I'm going to create a new function here called ACK, which will take in the current RabbitMQ context. And inside of this function here, we're going to go ahead and create a new called channel, which we'll call context.getChannelRep. Okay, and then we can get the original message from the context by calling context.getMessage. And lastly, we can call channel.ACK and pass in the original message. So this is how we can actually acknowledge that the message has been processed and take it off of the queue. So now back in our billing controller, we can go ahead and inject the RabbitMQ service. And so I'll change the import here to be how we've done it before from app.common. And then we can call this.rmqservice.ack and pass in the context. So only if this function did succeed and no errors were thrown, then we will acknowledge the message and it will be taken off of the queue. So now if I go ahead and save this file and our application is restarted, you can see we are no longer logging the message out because we have acknowledged it and it has been taken off of the queue. Okay, so for the next part in our project, we're going to actually add authentication to our system so that we authenticate the user before they're able to create orders, and we also authenticate our microservices so that we make sure that all messages received have authentication on them. We're going to use JSON Web Token authentication for this approach. And I have created a video already on how to implement JSON Web Token auth in Nest.js using Passport.js. I'll include a link to that video in the description where I actually go into detail on how to create this authentication mechanism. But for now, to save time, I'm going to copy over code from that existing video into our auth package so that we can take advantage of it and not have to rewrite it all. So in this auth folder, I'm going to go ahead and paste in that code, and of course this whole package will be in GitHub so you can take a closer look at it. I'll go ahead and remove our default source directory and rename this source. Now in addition to this, we're going to need to go ahead and install some packages so that we can take advantage of this auth library and implement authentication. So let's go ahead and install Nest.js.jwt, Nest.js Passport. We're going to go ahead and install bcrypt to be able to hash and unhash passwords. We're also going to install cookie parser so we can implement our JSON Web Token auth as secure HTTP only cookies. We're going to go ahead and install Passport itself, Passport JWT, and Passport local. Lastly, we'll go ahead and install some development dependencies here. So npm i-d, and then we'll go ahead and install types/cookie parser, types/passport JWT, types/passport local, and go ahead and let that install. Next, we should be able to open up our main.ts in our auth project and this bootstrap method should be completely empty for now. So next, let's go ahead and open up our auth.module and walk through what's going on here. So we have our database module from our common app library, as you've seen before, and we also have a users module here. So if we go ahead and take a look at the users module in our auth project, it's a simple module that will create a controller and a new mongoose schema here that will allow us to actually create and persist users. So we have a controller set up with a simple post route to be able to create a user, and we have a user service which will simply validate the request, persist the user after hashing the password. So we have some simple validation to make sure that the email doesn't already exist, and we simply validate the user as necessary by comparing the password in the database. So back in the auth module, we'll keep on going. We of course import the RabbitMQ module itself so that we can actually make advantage of the RabbitMQ service. And then we have the config module, as we've seen before. So we make this global, and we have a validation schema where we need to define some environment variables, the JWT secret, expiration, and of course the MongoDB URI, which we will set up soon. And have the end file path, which in our case will be in the auth project. Next, we have the JWT module itself, where we define the secret, which comes from an environment variable using the config service, and then we provide the expires in using the JWT expiration environment variable. Finally, we have our JWT strategy, local strategy, and auth service as providers, which use Passport.js to implement authentication. And lastly, we have the auth controller itself, which will host our routes to be able to log into our application. So by default, we have our first post route here, which will allow us to log in over HTTP. So in our case, this will use the local strategy, which will simply take the email and password and validate it using the user service. So if the username and password are valid, we can see we use the auth service to log in. All this is going to do is essentially create an authentication HTTP only cookie for this request and set it on the response. Now, finally, we have the JWT strategy, which is what we will be using for RabbitMQ, which will be able to pull the authentication off of a request. The JWT that is passed to our auth service is valid, and if so, it will return the user associated with that JWT. So with that brief overview of the auth service, let's go ahead and create that .m file. Now, amongst other variables, I'm going to go ahead and assign a new port to this service, because this service, the auth service, will actually be a hybrid application. We're going to be listening over HTTP so that we can still log in using post requests, but we also want to start this as a microservice so we can send messages to the auth service and validate requests. A port of 3001, and then we're going to provide a JWT expiration here of 3600 seconds, and then we'll have a JWT secret. So you can provide a JWT secret value here, and this can be any value you want, any long random characters. So we have the JWT secret, and then of course, as we have already done, we're going to need to provide the MongoDB URI. And finally, we'll go ahead and add the RabbitMQ URI while we're at it, and the name of the RabbitMQ auth queue, which we'll simply call auth. So with our .m information complete, let's open up our main.ts and start building this out. We're going to go ahead and of course create our app using the Nest factory.create method, where we pass in the auth module here. Next, we're going to go ahead and get the RabbitMQ service by calling app.get and giving it a type of RabbitMQ service and passing that in. And we'll change the import here to be from app common. So now that we have the RabbitMQ service, we can call app.connect microservice, pass in RMQ options here, and then call RabbitMQ service.get options. Now we'll provide the name of the queue. In our case, we know it's auth. Then we also want to set no-ack here to true, because with the auth service, we don't really want to manually acknowledge messages because we're going to be using the request response based message pattern instead of events. We'll also go ahead and set up global pipes here. So we'll call use global pipes and pass in the validation pipe so we can make use of class validator. Next, we'll go ahead and get the config service as well. So we'll call app.get config service here. And with that, we can now start our microservices by calling app.startAllMicroservices, and then we'll call app.listen so that we still listen over HTTP, on config service.get port here. So this is how we've essentially created a hybrid application that will list on an HTTP as well as the RabbitMQ queue that we've defined here. So with all of this set up, we are ready to actually add our auth application to our Docker Compose file. So of course, as we've done before, we're going to go ahead and create a new Docker file. So we can go ahead and copy this from an existing app. So we'll just take the one from billing here. The thing we'll have to change is the directory where we start the application. So in this case, we'll change this to auth and start it from auth. And so now that we have this Docker file defined, let's open up our Docker Compose and we can add a new service in here. So let's go ahead and add a auth service. Now we'll specify the, of course, build section first. So the build section will have a context where we provide the root context as always. We're going to specify the Docker file itself, which will be in apps auth Docker file. Next, we'll specify the target, which as before will be the development stage. So now that we set the build section up, we'll provide a command here to run, and this will be npm run start dev auth. Let's go ahead and specify the ports. And now in this case, it'll be on port 3001 as we've set up in our env. And speaking of env, we can go ahead and provide the env file here, which we know will be /app/auth.env. Finally, let's go ahead and set up the depends on section, which will set a list of services that need to be started before this one does. So in our case, this will be all of the MongoDB services and then RabbitMQ itself. So let's go ahead and set that up. Lastly, we'll go ahead and define our volume section here. So as we've done before, we'll go ahead and mount our entire project in the user source app directory. And then we'll go ahead and mount the user source app node modules here. So now that we've set the auth up, let's go back up to our orders service here. And let's go ahead and flesh this out. So in addition to depending on MongoDB, our orders app should wait until billing has started up. It should wait until auth has started. And it should also wait until RabbitMQ has started. Similarly, billing should also wait until RabbitMQ starts, and it should also wait for auth to start. With that complete, we should be able to stop our current application and then call Docker Compose up --build -v and go ahead and let our new auth project build and our application restart. So you can see our application has started up here, and if we go ahead and resave our auth app, we should see in our logs the auth application restart, and what we're looking for here is to see that the Nest application successfully started, as well as our microservice successfully started for our auth application. So auth is up and running, which is great to see. So now we should be able to open up Postman and launch a HTTP post request at localhost 3001 /auth/login. And of course, this will correspond to our auth controller here, where we have auth/login, and we can see I have a body here where I have an email and a password. Now if I go ahead and send this request, we can get a 401 response because this user does not exist in the system. Now if we open up our user's controller, we can see how to create a user. It's simply auth/users with an email and password body. So I'll call auth/users and send a request to create this user. Now I already have a user with this email, so we can see our validation works correctly. So I'll use test2, create the user. We can see we get the user back with the hash password. And now if I change this route to login and send the request, we can see we get a response back. But importantly, if you look under the cookie section, we can see we're getting a JSON Web Token cookie back. And so now at this point, we have a JSON Web Token we can use to make further requests in our system, like our orders application. So let's go ahead and set up authentication in our orders application using this JSON Web Token flow. Okay, so in order to implement authentication in our system for both HTTP and over our RabbitMQ service, what we're going to go ahead and do is create a new auth folder inside of our common library. Then I'll go ahead and create a new auth.module here. So this would be a normal Nest.js module, and we'll go ahead and export a class called auth module. Now I'm going to go ahead and implement a Nest module here, and that's because I want to use the configure method to be able to apply some middleware. Whichever other module imports this auth module, I want to implement our cookie parsing so that we are able to parse incoming cookies and look for a potential JSON web token. So I'm going to call consumer.apply and then call cookie parser here, which will take cookies and add them to the recurrent request object. So I want to go ahead and apply this for all of the routes in our system so that we are extracting cookies from every route. Additionally, I'm going to go ahead and create a new services.ts file here, which, as we've done before, will export the current service we're looking at. So in this case, we're going to export the auth service. So we'll go ahead and export auth, and this will be our injection token that we can now use. So in our auth module, probably guess what we're going to go ahead and do. We're going to add an imports array here where we import the RMQ module, and we will call register and give it a name of auth service because we want to be able to communicate with the auth service here. And then we're going to go ahead and re-export the RMQ module so that any other module that uses this one will have the auth service available. So now that we have this auth module, I'm going to go ahead and create a new JWT auth guard in this auth folder. And this guard will be a normal injectable class from Nest.js. And so we'll go ahead and export the JWT auth guard, which will implement can activate from Nest.js common. We'll go ahead and add a constructor where we, of course, follow that same pattern using the inject decorator here and inject the auth service so that we can communicate with the auth service that we've set up. So we'll go ahead and call this private auth client, which will be of type client proxy from Nest.js Microservices. Then we'll go ahead and implement the can activate function, which will implement this interface here. Now, importantly, we get access to the execution context, so we can actually see if this is going to be an HTTP or a RabbitMQ request. So let's go ahead and first do that. I want to extract the authentication value or the JWT from the recurrent request, depending on if we're HTTP or in RPC mode. So let's create a new variable here called authentication, and we'll call get authentication with passing in the context. We of course need to implement this method, so we'll put our new method called get authentication, which takes in the current execution context. And let's go ahead and define the authentication value here, which will be of type string. Next, we're going to go ahead and say if the current context.getType is equal to RPC, which will be the case if we're communicating over RabbitMQ, then we'll say the authentication will be equal to context dot switch to RPC dot get data, which will be the data object being sent, and then we'll pull the authentication value off of that data object. Otherwise, if the context.getType is equal to HTTP, then we're going to pull the authentication off of context.switch to HTTP .getRequest.cookies.authentication. Because if you recall, our authentication over HTTP is implemented with cookies, and cookie parser will automatically add this to a cookies object on the request. Lastly, we can now check to see if authentication is currently provided, and if it's not, then we'll go ahead and throw a new unauthorized exception and say no value was provided for authentication. Otherwise, we'll go ahead and return authentication. So now we actually have the authentication or JWT based on whether or not we're in HTTP or in RPC mode. Lastly, we'll go ahead and return this .authClient.send. Now, unlike emit, send will send a request to a RabbitMQ microservice and wait for a response back. So we'll specify the actual message pattern we want to use here. And in this case, we'll call it validate user that we're sending to the authentication service. And we will provide an object which has the authentication property here and pass in our authentication JWT value. Now we actually want to pipe this RxJS observable so that we can add some additional functionality here. In particular, we're going to use the tap operator from RxJS, which allows us to specify side effects on our calls. So what we're going to do is we're going to get the response back from the auth service. And with that response, I want to add the user to the current request or data object, depending on if we're using HTTP or RPC. So I'm going to pass in the res and context to this function. And finally, we'll go ahead and add a catch error operator from RxJS, which will catch any errors thrown in this observable chain and throw a custom error. So in this case, if there are any errors thrown, like for example, the auth service threw an unauthorized exception, we want to rethrow that here and say that our guard cannot activate the current route. So let's go ahead and implement this add user function below. We will add a new add user function, which takes the user of type any and gets the context, which is the execution context. So as I said before, we'll check to see if the context.getType right now is RPC. And if it's RPC, then we will call context.switch to RPC get data, and we'll actually add the user to the data object. So we'll do it like so. Else, if the context is HTTP, so get type equal to HTTP, then we will simply attach the user to the request object. So we'll call it get request and attach the user to the request object here. So to test this functionality out, we're of course going to need to open up our auth controller and make sure we define this route here for RPC calls. So we're going to go ahead and specify a message pattern here, which is similar to the event pattern we've used earlier. So we'll just specify the actual pattern that we want to match. Here in the case, it's called validate user. And all we're going to do in validate user, we want to return the user back to the calling service if the authentication succeeded. So what we're going to do is we're going to call use guards here and pass in the JWT auth guard. That is from our auth package. So if that succeeded, then we can extract the current user from the given request and simply return the user back to the calling service. So if we take a closer look at this JWT auth guard, it's going to implement the JWT strategy. Now, if we look at the JWT strategy, that will extend the passport strategy, we can see we're extracting the JWT from the request. So in our case, we know we provided this in our JWT auth guard. We passed that authentication object here. So we're pulling the authentication JWT off the object and we're validating it based off our JWT secret. And if this is valid, then we call the user service to get the user based off of the user ID on the token payload. So if this will succeed, Passport will actually automatically add the user to the current request or data object for us. So what we need to do is we need to modify our current user decorator here and add one more bit of logic to say if our context.getType is equal to RPC, then we call context.switch to RPC.getData.user. Because by default, Passport will attach the user to the data object in RPC, just like it does for HTTP on the request object. Now our auth controller, we are able to extract the user, no matter if we're using HTTP or RPC, and then return it. So let's go ahead and try this out by opening up our orders controller. Now in our create order function here, we can actually use guards and pass in that JWT auth guard. Now I'm gonna go ahead and import JWT auth guard from the common lib, so that we want to actually change the import here to app/common. So to go ahead and actually import this correctly, make sure we open up our index.ts in our common library, and we'll go ahead and export star from auth/auth.module, and we'll do the same thing for our JWT auth guard here. So now in our orders controller, we are using that JWT auth guard. Now to make sure this works properly, make sure in our orders module, we go ahead and import the auth module. And this should also be coming from app.common. So we'll go ahead and add the auth module import here and remove this one. Lastly, make sure we change our import from cookie parser here, let's import star as cookie parser from the cookie parser library. So once we've imported the auth module in the orders module, we should be able to apply this JWT auth guard. Let's see if it works by using the request decorator here from Nest.js common, so we can actually extract the request object. And let's log out the request.user, because if this auth guard succeeded, we should now have the user on the request object. Now finally, before we can test this all out, we need to make sure in our orders M file that we're actually defining that auth queue, which is what we'll use to communicate with the auth service. Because if you recall, in our orders module, we go ahead and import the auth module. Now the auth module is going to use the auth service. Now, if we remember to register it, we need to have the auth queue defined in our environment file. So in order to make sure this is the case, open up our .env in the orders application, and we'll define the RabbitMQ auth queue here and set it equal to auth. With all that in place, let's go ahead and restart our application so we reload that env information. Once your application is started up successfully, we can open up Postman, and let's send another request to localhost 3000/orders with our example order here. So we'll go ahead and send this request, and we can see it succeeded. Now if we open up our terminal here, we can see in our orders application where we logged out the user on the request object. So we can see that our auth actually worked properly, and then our auth microservice validated the user as we'd expect, and we can still see our billing application billing the user here. So now that we have authentication working for a HTTP request, let's do the same exact thing for our RabbitMQ service. So guards can apply equally to RabbitMQ services. So if we open up our billing controller, see our handle order created event here, we can actually add another use guards here and apply the JWT auth guard, and this will be coming from app.common. So we'll add the JWT auth guard here, and now we can actually protect our RabbitMQ routes to make sure that we have a JSON web token being passed to this route. Now, just as we did in the orders application, we'll go ahead and have to supply the RabbitMQ auth queue to the billing application so that it can be used properly. And as you'd expect, we'll have to go ahead and import the auth module. So we'll go ahead and add the auth module, which we can import from auth common here. So with this route protected with our JWT auth guard, we can now see that if we send a request to create an order, we can see that it still succeeds. But now if we go look at our terminal, we can see we have an exception being thrown in our billing application because no value was provided for authentication when we sent this event. Moreover, if we actually resave the billing application, we can see as it restarted, it also has this error rethrown over and over again. And this is the same as we've seen before. We weren't able to acknowledge that this event actually succeeded because an error is thrown in our JWT auth guard, so we are replaying the message over and over again every time our application restarts, which is a good thing because this is a valid failure and we want to handle that. So to make sure we're providing authentication to our billing service, in our create order function in our order service, we'll go ahead and add an additional parameter here called authentication, which will be of type string. And now when we emit this order created event, we can also add a property here called authentication, which will be equal to the auth that gets passed in here. So now in our orders controller, we're going to go ahead and pass the request.cookies.authentication value. Because since this is HTTP, we should expect that cookie parser has added this request authentication JWT value to our cookies object. Now back in Postman, if we send a request, we can see our whole flow complete successfully. I'll send a request and we can see billing now correctly billing the user. And additionally, we can see that on the data or request object itself, we have the authentication JWT value passed, and as well as the user has been attached to the actual data object. which is great to see. So our JWT flow is working properly, and we have protected our HTTP and RPC calls. So with that, we've implemented a full working microservice architecture in Nest.js with JWT functionality using RabbitMQ. I hope this video has been helpful for you, and if you'd like to see ones in the future, make sure you subscribe. And I'll see you in the next one.